Hello and welcome to NPTEL classes. Today I am here to solve chemistry class 12th NCERT problem 2.33. Let me read the problem. 19.5 gram of fluoroacetic acid is dissolved in 500 gram water. Depression in freezing point of water observed is 1 centigrade. Calculate the Van 't Hoff factor and dissociation constant of fluoroacetic acid. Problem is based on concept of depression in freezing point, which is a colligative property and its magnitude depends only on amount of solute and not on nature of solute. And idea is solution always freezes at lower temperature than pure solvent. This decrease in freezing point of solution upon addition containing solid solute is called a depression in freezing point, and here solvent is water. Here solvent is water, solute is fluoroacetic acid, and 19.5 gram of fluoroacetic acid when dissolved in 500 gram of water results in depression in freezing point of water equal to 1 degree Celsius. In Kelvin it will be equal to 1 Kelvin. Now we have to calculate Van 't Hoff factor and dissociation constant of fluoroacetic acid. Now let me practice its solution. For solution of non-electrolytes, if solute is non-electrolyte, expression for depression in freezing point delta TF is equal to KF into M. If solute is non-electrolyte, expression for depression in freezing point is delta TF is equal to KF into M. This is depression in freezing point, that is difference between freezing point of pure solvent and freezing point of solution. This is molar depression constant. This is molarity of solution. But for solution of electrolytes, when solute is electrolyte which undergoes ionization in water resulting in increase in number of particles in solution, expression for depression in freezing point is delta TF is equal to I into KF into M. So difference in expression of freezing point for solution of non-electrolyte and solution of electrolyte is only in I factor, which is introduced in the expression of depression in freezing point for solution containing electrolyte, and I is called Van 't Hoff factor, which we have to calculate. Van 't Hoff factor. I is Van 't Hoff factor, which we have to calculate. Van 't Hoff factor. Now for calculation of Van 't Hoff factor, we need depression in freezing point, that is given 1 degree Celsius, and in Kelvin it will be 1 Kelvin. KF for water is 1.86. Molality first we need to calculate. Molality is not given, but some data is given from which we can calculate molality. So our first step will be calculation of molality. Molality of solution will be equal to weight of solute, dissolved weight of solute multiplied by 1000 divided by molar mass of solute multiplied by weight of solvent. W2 is weight of solute. Solute is fluoroacetic acid, and its weight is given 19.5. Its weight is given 19.5 multiplied by 1000 divided by molar mass of solute. Molar mass of fluoroacetic acid is 78. Weight of solvent given is that 19.5 gram of fluoroacetic acid are dissolved in 500 gram of solvent. So weight of solvent is 500. Now from here we can calculate molality, and I have already done my calculations. It comes equal to 501 502,000. It will come equal to 38. 38 divided by 72 will come 0.5. So molality of solution which contains 19.5 gram of fluoroacetic acid in 500 gram water is 0.5. Now we will substitute this molality here in order to find value of Van Hoff's factor. I will be equal to ratio of depression in freezing point delta Tf and Kf into molality. I will be equal to ratio of depression in freezing point is given in question 1 degree Celsius, and in Kelvin it will be 1 Kelvin. Kf for water is given 1.86. It is constant for water 1.86. Molality I already calculated is equal to 0.5, and I need to calculate I, and I have already done calculations here also, and I comes equal to value of I comes equal to 1.07. Value of I comes 1.0752. This is value of I which we need to calculate. Not only we have to find value of I for this solution, we have one more parameter to determine, that is dissociation constant of fluoroacetic acid. Dissociation constant of fluoroacetic acid. Here we have to use Ostwald's dilution law. Ostwald's dilution law. As per Ostwald's dilution law, dissociation constant of fluoroacetic acid is equal to C alpha square divided by 1 minus alpha. Dissociation constant of fluoroacetic acid we can calculate by this equation, where C is molality, alpha is degree of dissociation. First we will calculate molality. C. Molality is equal to W2, or I will use this approximation that colligative property is strictly true for dilute solutions, and in dilute solutions volume of solution is taken equal to volume of solvent. But here volume of solvent is not given, mass of solvent is given, and that too water. Density of water is 1. So because density of water is 1, its weight and volume will be same. If its weight is given 500 gram, its volume will be given 500 ml. And using expression of molarity, that W2 molarity is equal to W2 into 1000 divided by M2 into volume of solution in ml, I will be able to calculate concentration, that is molarity of this solution. Dissolved mass of fluoroacetic acid is 19.5 multiplied by 1000 divided by its molar mass is 78, and volume of solution in ml I will take equal to volume of solvent, considering solute is dilute. Volume of solvent is water, its volume will be equal to its weight, which is 500 grams, so volume will be 500 ml. And after solving this, here again we will get that molarity of the solution will be equal to 0.5, which is same as its molarity. Here molarity will be equal to its molarity. Now I need to calculate degree of dissociation. I know relation between Van Hoff factor is related with degree of dissociation by this equation. Degree of dissociation is equal to I minus 1 divided by n minus 1. So using this equation I can calculate degree of dissociation. For that I need to know n. And where from I will get n? I will consider its dissociation CH2FCOOH. Fluoroacetic acid undergoes dissociation like this. It will give CH2FCOO negative plus H positive. Now one mole of fluoroacetic acid in water furnishes 2 moles of ions, or I can say one particle of fluoroacetic acid in water undergoes dissociation and forms 2 particles in solution. So n here is 2. I will get alpha is equal to I minus 1 divided by 2 minus 1. Alpha will be equal to I minus 1. Now I is given. I already calculated Van Hoff factor. I calculated in step first 1.0752 minus 1. It will come equal to 0.0752. Alpha I got equal to 0.0752, which is less than 1, confirming that it is not strong electrolyte, it is weak electrolyte, because its degree of dissociation is less than 1. Now I will substitute value of C and alpha in expression Ka in order to find acid dissociation constant of fluoroacetic acid. It will be equal to C is 0.5 into alpha is 0.0752 whole square divided by 1 minus alpha, 1 minus 0.0752, and here again I have made my calculations in order to save time, and value of acid dissociation constant of fluoroacetic acid comes equal to 3.07 into 10 to the power minus 3 into 10 to the power minus 3. So I solved both the parts. In part first I had to calculate Van Hoff's factor, and in part second I had to calculate acid dissociation constant of fluoroacetic acid. If I recall, this problem was based on concept of depression in freezing point, and for solution of non-electrolyte, expression for depression in freezing point is this, but for solution of electrolyte, expression for depression in freezing point is this, and here one additional parameter is incorporated in equation, that is I, which is named as Van Hoff factor. And in this problem I have to calculate Van Hoff factor. Van Hoff factor will be equal to ratio of depression in freezing point, Kf, and molality. Depression in freezing point was given in question 1 degree Celsius. In Kelvin it will be 1 Kelvin. Kf for water is 1.86. So first I needed to calculate molality in order to find Van Hoff factor. Molality, for calculation of molality, dissolved mass of fluoroacetic acid was given 19.5, and 19.5 gram of fluoroacetic acid were dissolved in 500 gram of water. So it was easy for me to calculate molality of solution, knowing that molar mass of fluoroacetic acid is 78, and molality I got 0.5. I simply substituted molality, given value of depression in freezing point 1 Kelvin, molality equal to 0.5, and Kf 1.86 in this expression. I got Van Hoff factor is equal to 1.0752, which is greater than 1. Now I needed to calculate dissociation constant of fluoroacetic acid. I used Ostwald's dilution law, that expression for dissociation constant of fluoroacetic acid will be equal to C alpha square divided by 1 minus alpha, where C is molality and alpha is degree of dissociation. Molality I can calculate using expression of molality, but here I need volume of solution. So I utilized the approximation that Colligative properties are strictly true for dilute solutions, and in dilute solutions volume of solution will be equal to volume of solvent, and solvent is water, its density is 1, and volume of water will be equal to mass of water. Mass of water was given 500 grams, so volume of water will be equal to volume of water, which will be the volume of solution, will be equal to 500 ml. I substituted values of given parameters here in this expression of molarity and got molarity again equal to 0.5. So for this solution molarity is 0.5, molarity is 0.5. Next I had to find degree of dissociation. I said that degree of dissociation of electrolyte and Van 't Hoff factor are related by this equation. Alpha is equal to I minus 1 divided by n minus 1, where n is number of particles formed after dissociation of one particle of electrolyte, and for that I considered dissociation reaction of fluoroacetic acid, and I find that 1 mole after dissociation gives 2 moles. One particle after dissociation forms 2 particles, so value of n for fluoroacetic acid was 2. After substituting value of n equal to 2, I got relation between its degree of dissociation and Van 't Hoff factor is alpha is equal to I minus 1. I calculated in step first 1.0752 minus 1 degree of dissociation, I got 0.0752, and now I used both molarity value, magnitude of value of molarity and magnitude of value of molarity and value of degree of dissociation in this expression, and got acid dissociation constant of fluoroacetic acid is 3.07 into 10 raised to power minus 3. Information is that degree of dissociation is less than 1, indicating that fluoroacetic acid is a weak acid or it is a weak electrolyte, or else I can say dissociation constant is of the order of 10 raised to power minus 3, indicating that it is a weak acid, weak electrolyte, and Van 't Hoff factor is greater than 1, equal to 1.0752. Class 12 students, this is the problem which I have got for you today. See you day after tomorrow with one new problem, as tomorrow is turn of class 11th. Allah Hafiz.